Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking Seco for sponsoring today's event. Seco is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is entitled The Challenge of Navigating an Ever-Changing Software Ecosystem. Before we begin, I'd like to briefly review the format of today's proceedings. This event will be 1 hour long. We have one presenter who I'll introduce in just a moment, and there will be a Q&A session after the presentation. Now, I'm very pleased to introduce today's speaker. Dario Freddi is the CEO of Seco Mind. Whenever you're ready, Dario, you can take it away.
Thank you very much, Max, and hello, everyone. I would like to talk about what's changing in the software space for IoT today and some of the experiences and challenges that we've met as a company and as an individual over the last years in what I will definitely call a big turmoil in what is currently taking the IoT market by storm. My name is Dario Freddi. I'm heading the Seco Mind division in Seco. We're taking care of building our main IoT platform named Plia. I will get back to that later, and I will show you how we fit into the ever-changing environment that we are facing in the IoT market every time we go out to the market, which is quite often these days. So my background, I used to be a software developer back in the days, and I still like to take up my IDE from time to time. And definitely, I've always been passionate about how the software ecosystem is evolving, how developers are evolving, and how the market is trying to answer more thorough and challenging questions that the developer community is trying to put together as the technology evolves and the use cases evolve. And I, for myself, like to be writing these kind of things and try to provide something that makes sense for the wider community. And this consideration usually comes out of the realization that the IoT has been changing quite substantially over the last few years. I will dare to say that this change is not something happened yesterday. It's something that has been ongoing for a few years now, but definitely, IoT back in the day used to be the IT plus OT thing, right? But as a matter of fact, if we look backwards and we look at what has happened in the first wave of IoT, as I like to call it, IT was really the internal customer that the IoT was serving. Because of course, the main need was doing fleet management, remote support, any kind of operations that we would dare to say it's commodity as of today. And a lot of different providers, platforms, and great products out there are offering. And nowadays, let's say that whether it's in the industry, whether it's in your house, in your home, when you buy a product, you kind of expect it to be connected to the internet, and you kind of expect a set of features, especially if you're paying a premium. As such, I will say that this kind of wave has reached maturity quite a few years ago. But if we look forward and if we look at what really has taken the market by storm over the last years, so the wave of data and data above everything else, IoT is definitely living a whole new spring. And as a matter of fact, the user of the IoT itself is changing. So if earlier back in the days, people managing fleets would have been the main users of IoT, now people using data are the main users of IoT. And most of the cases, these are the end users. If you think about industrial use cases, it would have been very, very weird for a machine operator only 5 to 10 years ago to have an app or have some kind of digital instrument that could control a CNC machine rather than an industrial machine, or even medical equipment. Nowadays, it's starting to be the norm for top-end products. And most of all, even professional users are asking for different kinds of interaction when it comes to devices. But if you go one step further than this, people start expecting the fact that these machines will be able to do some things by themselves. The whole artificial intelligence thing that these days is mostly making the headlines for generative AI is still quite hot when it comes to assisted or automated decision making. As such, I think that the way by which we give meaning to the term IoT, which as you all know very well, it's something that has been boggling minds for quite a while. is ever changing. And today, to me at least, it means how can I get my device to take some decisions or help me take some decisions autonomously or in an assisted way that can help me do my job. So this, of course, presents a set of changes, and changes bring challenges and opportunities for those who build machines. Historically, I've been always working in the segment that was assisting people building digital products, whether it's hardware, software combined. And as such, the challenges for these people have changed dramatically over the course of the last years. But what's very interesting today is that OEMs are faced all around the board with the real opportunity of monetizing services. Don't forget that, of course, when you build a hardware product, there is always a challenge in ensuring that your customer will stick around. And for consumer devices, we are quite used to, change something from maybe 12 to 14 months to 24 months or so. But when you go into the industrial realm and into the industrial space, some machinery sticks around for decades at times. And of course, for those who build these machines, it's very tricky to keep the whole thing rolling when it comes to the customer being around, the customer being engaged, and the customer maybe choosing you when it will be time for revamping or expanding their fleet. Now, when you get data flowing, of course, you have ways to keep your customers, your users engaged. We have learned this in the mobile market when it was time for the apps. So it's about 10 to 15 years ago now. And the same paradigm is kind of being leveraged to make it so that professional users can feel attached to something they buy because there is a consistent and continuous interaction. This is enabled by the IoT. But once again, we're no longer talking about managing devices. We're talking about managing data that comes out of those devices. And that's just the tip of the iceberg, because another big trend that is happening outside of the IoT community, but is very relevant to the IoT community as a whole, is the fact that companies are looking more and more into being data-driven, not just from a financial perspective, but also from an operational perspective. Again, there's different degrees of maturity here. A lot of companies that we know and we love have been data-driven from their users for quite a while now. But when you look at the broader landscape and maybe some verticals or some technologies that have been maybe lagging a little bit behind for the most diverse reasons, this is definitely not true. As a matter of fact, being capable of pulling together all of the data that comes from and out of your business is a massive challenge. And just recently, we've had the tools and, of course, the technology that is priced at the right point, because, of course, that's a big part of the game, to make it so that these data can be put into action and can be put into motion. And when we talk about a fully data-driven company, you cannot underestimate the contribution from the field, because ultimately data from the field will be a big portion of what you will consider. As such, IoT becomes really a core component of the technology stack. We have been used to see IoT as a silos, in which basically you will put data, have your service, have your applications, have your whatever, and eventually these data might flow somewhere else. Nowadays, IoT is conceived as one of the core data sources within the company, and as such, it has to be integrated with the rest of the data sources that you have out of your internal systems. This is also true for developers. If you are building, let's say, coherent and convergent product, you cannot underestimate the contribution from any of the data layer you're dealing with. As such, IoT is really living a new spring as a data source more than an IT instrument that is to be managed by the fleet manager or anybody else within the company. But this comes at a cost, of course, because on one hand, this really kind of puts the plug-and-play solutions in a very difficult spot. As much as we want to collect data, we also want to differentiate. I'm sure that out there, listening to this, there's a lot of people building their next big thing and building something different from what's out there. And if data is really taking over, one of the biggest differences is what data you can collect and how you can do that. As such, it is very difficult that on the market you will find an off-the-shelf, one-size-fits-all solution that is really ready-made and ready to accommodate all of your needs when it comes to managing your data and ensuring that your data goes through. And of course, that's pretty obvious. You need to make it so that this data can be meaningful at the very end of the chain. So there has to be something else, that's something that you can install as an agent and you can just plug in into your front end and it just works. And we need to find out how to do this. And of course, managing a silo is something, but managing a fully integrated IT infrastructure is very difficult. And of course, this means that companies that maybe up until a few years ago disregarded the IT challenge rather than they didn't really care a lot about how to settle together an infrastructure that made sense from a software point of view are now facing the challenge on how to make this work, and most of all, how to make this reliable and still cost effective, because having everything joined together is definitely quite the challenge, and it's something that companies need to face, and users as well. Luckily, we've been looking at technology evolutions over the last few years that made some of those things quite more affordable to everyone. And I'm not just talking about money, I'm also talking about the learning curve, because of course, so once again, developers are a central figure in all of this, because these integrations have to be done somewhere. And of course, we have seen the rise of low code and no code solution over the last 5 years. And it's to me, it's really a jargon to mention that integration and let's say that separation amongst layers has to be extremely well thought to ensure that whoever needs to step one step beyond what you're doing will find a very nice greenfield to work on, and not something which becomes very quickly a big nightmare for anybody doing some work on top of this. And when we're talking about silos, definitely we are talking about something that is very difficult to integrate, very difficult to migrate to something else, and very difficult to manage overall. In general, the fact that you cannot get what you want from the market off the shelf, as in I'm going to buy a subscription and that's going to work 100%. You don't really need to go the other way around and rebuild the whole wheel yourself, because it doesn't make any sense. And most of all, the technology challenge is really, really more complicated than it looks like. And a lot of people have found out the wrong way, and most of all the hard way, I would dare to say, given that there's been a huge ratio of projects that had to be rethought from the ground up, not really because of business needs, but because the infrastructure and the technology challenge was way more difficult than initially thought. And if we accept this notion, of course, we need to also say that monoliths are no longer what we're looking for. Because once again, monoliths have a lot of, let's say, good advantages and a lot of nice things to have, which is mainly, let's say, point and click, make it run, make it work. But ultimately, they also have a lot of limitations that are acceptable if we are providing commodity features, as in, I want to give something everybody else does, so it's very likely I'm going to find in the market something that allows me to do so without a lot of effort, and who cares how it fits within my infrastructure. But if I am looking into extracting value from data, then again, I am no longer looking for something that doesn't really integrate and is not static at all, because the evolving needs are really a staple of this kind of endeavors. As such, it is pretty obvious that the more flexible my infrastructure and my architecture is, the easier it will be to adapt it to incoming requests. And don't forget that if you're starting to listen to your users rather than your internal customers, your users are much more sensitive to change and much more sensitive to quality in a way, because they will stop buying your products or stop using your service if you don't treat them right. As such, being quick and taking swift action is very, very, very important. Then, of course, there's the control topic, because if we agree on the fact that IoT is a core data source, and most of all, that data is playing a bigger role within the whole company infrastructure, then we also need to make sure that we have all the right tools to ensure that if anything goes wrong, there are means or some way by which I can retain control and I can move forward. It cannot be that if something happens, I lose control of one of my core data sources. As such, when making choices, when building infrastructures, when building architectures, one always have to consider, what am I going to do if this very, very unlikely thing happens? Because it might as well not happen, but if it does, you might as well be screwed. So retaining control has to be done in a smart way. Once again, control never really means that you're doing everything yourself. Control means knowing what you're doing and knowing the outcome of all the wrong things that can happen along the way. But a lot of people misunderstand control with ownership. Ownership is one thing, control is a different thing. And I will say that ownership is usually a liability and a burden, whereas control is an asset. So it's very important, I think, to keep this in mind when building an infrastructure. This really applies to everything, I believe, not just IoT. But once again, if we are accepting these notions, then IoT and the larger infrastructure that you will be building within a company or a project doesn't really change in terms of the philosophy by which you have to build it. And most of all, well, and this goes to the hardware people, software is no longer nice to have, because as much as the commoditization of software is inevitably happening, if we are building value-added solutions, if we're building our own project, our own product, then we need to take software into account. And it is as important as the hardware portion. As such, it has to be treated in the very same way. You need a dedicated team, you need knowledge, you need control, you need to ensure that the ownership of the right components is there. So you need to own the tip of the iceberg. Just as if you were building a new hardware product, you will own the last mile and you will outsource the rest of the CPU, the board, rather than the module or anything else that you might be building in that situation. And you have countless possibilities. Once again, let's say, identifying what has to be controlled and what has to be owned is always key in terms of the total cost of ownership that comes after your product. And so once you accept that, it's pretty obvious that the software process has to be controlled in a very similar fashion to the hardware process, and it is no longer the cherry on top. It is part of the whole sandwich. As such, it is very important, I think, to embrace a mindset in which your products are now a mixture of different technologies that are inevitably becoming more complex, because that is the trade-off you get for building cooler stuff. So how do we get there? These are just some of the advice I will give based on my own experience and having looked at quite a few projects in the IoT, but more in general in the software infrastructure realm, in which ultimately these kind of philosophy, this kind of rule of thumbs have been very successful in delivering quite the product at the very end of the journey. The first thing is definitely decoupling. And this really goes hand in hand with the monolith concept. Ideally, you need to decouple infrastructure, physical and virtual, and I will get there in a second, from the software. Because it is great to have something very well integrated top to bottom, but once again, it's all about the control. So if you get a monolith hardware to software, it is very convenient. It might look very convenient, but the sooner you need to drift a little bit away out of the fence you built yourself, then you're going to start finding out what kind of problem you brought to your table. It is actually quite better to rely on something that can be easily integrated, but is still decoupled, so that if you for any reason have to make a switch, whether it's on the hardware, whether it's on the software, whether it's in the overall approach to the product you're building, you can still do that. Of course, you will have to go through a step of integration, but the challenge that as technology providers we have is to make this step as smooth as possible. And I think that not just at Seco, but all around, there's a lot of companies, a lot of developers doing a great job in giving out perfect tools that can integrate anywhere with the slightest effort possible. And when I'm talking about virtual infrastructure, of course, I'm talking about the cloud. So don't underestimate the kind of dependency you might get on a cloud provider or on a software service. Once again, it's all about control. So it is obvious you cannot own a physical or virtual infrastructure in the cloud, because it will be pretty inconvenient unless you are so successful that it's justified, and I wish you guys are. But ultimately, it's about making sure that what is going to be running on that infrastructure is not tightly dependent or tightly coupled with the infrastructure you're running, with the software you're running, sorry. So ultimately, prefer open solutions. So the market is providing you with a lot of different solutions that are open source, open in nature, and can be very easily adapted to whatever you're building. And these are usually the smart choice. If you look around, most of the industry and most of the software verticals eventually migrated to open source once they reach maturity, because of course it's all about control. And I will probably stop saying that because I've been saying this quite enough for the first 20 minutes. But anyways, it's very clever to have this kind of approach, because of course the degree of dependency that you get out of your vendors is decreasing. And most of all, you can build your own knowledge and you can build your own skills within the company and make it so that your infrastructure will eventually be decoupled enough to make sure that there is no longer a single point of failure that can compromise all of your approach to the product or the company you are building. The second thing is adopt middleware and frameworks. Why? Because ultimately, decoupling works very well as long as you have the right tools, and most of all, as long as you don't have to build everything yourself. I mean, if I was building a home device, an industrial product, I don't know, a maker device or something else, the first thing I will probably ask myself is, what do I want to do in terms of what will my product do? And the technology should be chosen based on what the product will do rather than building technology for the sake of it. Of course, if we are having fun over a weekend, that's going to be fine. But if you're looking into a product that has to go to the market, has to be reliable, and eventually has to be successful, you need to have a situation in which middleware and frameworks can ease your job. So a lot of people, a lot of companies, I've seen this happen quite a while, always fall in the trap of let's build everything ourselves because there's nothing that fits our exact boat. Maybe yes, but usually you can source on the market a lot of tools that can ease your job quite dramatically. And in the long run, if you adapt to them or if you adapt them, depending on your horsepower, they really make a difference. As such, I wrote in the slides, it's pointless to take care of technology challenges that don't relate to your core business or your core product, I will add. And definitely it is a situation I see quite often when I go talk with customers, developers, and a lot of other people. It's, I think, very important always to keep in mind that you need to be extremely laser focused on what you're building and your competitive advantage, and try as much as possible to, let's say, leave aside everything that really doesn't bother you when it comes to will my product be successful? Because the only question you need to answer is it going to be reliable? Is it going to be, let's say, the right technology and everything else? But don't build it yourself. Spare yourself from this, because ultimately it will be a burden that you will have to deal with for quite a long time. And a lot of projects, very promising projects, have failed on top of this, and not just in IoT, pretty much everywhere. In software, we used to say, don't reinvent the wheel. That's always a good advice. Of course, though, this brings us to the low-code approach. I might have said no code at all, but ultimately you need to write some code because if you're building your own product, it's likely that at some point you will have to open up a terminal, an IDE, and write some code. But this is not a good reason to write a lot of code. You should try to write as least code as possible. And really, that's because the total cost of ownership, once again, of your product will increase dramatically the more code you write. So the point is, be in a position in which you can evolve your service ecosystem, your front end, your back end, your whatever you're building in the quickest and swiftest possible way, because speed is always a dramatic factor in making sure that your project will be successful eventually. So having a low-code approach, which means basically choosing the right framework and the right middleware for what you're building, is usually, let's say, drawing the line between those who build products between and those who don't build products but solve problems eventually that create themselves. So really, it's important to make sure that when you're starting off, you have all the right tools and you know that you're going to code just what matters to your product and not what matters to something else, because maybe you just made the wrong choice, or you need to go back to the drawing board and ensure that your architecture is sound. If you feel like you're writing too much code, usually it's always a red flag, and you should ask yourself whether it's really needed. Spoiler, sometimes it indeed is. Or if there is something you're doing that you could probably let's say, lay off and do something else by acquiring the right framework or the right tool. And then, of course, if you're building an IT project, data first, because today, over-the-air updates, fleet management, and all the rest, it's something you can source from the market pretty easily, and it is an off-the-shelf product. There's a bunch of them I could mention, and you, of course, know a lot of those. But remember that IoT is becoming about the data. So it's really not about making sure that you can manage your fleet. That's kind of a given in 2023. But you need to make sure that the data features that you need out of your devices will be supported by the infrastructure you are building. And as such, this is really something you need to keep in mind when you get to making decisions and going to the drawing board once again and building up your own architecture. This definitely is, I think, just some of the things I will consider, but probably the main ones amongst I'm starting a new IoT project. What should I be, let's say, more careful about? That is definitely a non-exhaustive but interesting list. And if you are getting there, then you also need to understand what kind of factors are within the ecosystem that you're talking about. I try to simplify and summarize a very fragmented scenario that most of you guys will surely know, but ultimately, I think it's always relevant to keep in mind that the value chain of the IoT is shifting dramatically. And maybe just a few years ago, a number of these players were separate players or were, let's say, consolidated players, and the landscape is shifting as we speak, because as technology needs evolve and as users need evolve, the market and the technology is adapting. Nowadays, I will say that it's really about three main stages. The first one being infrastructure. And infrastructure to me, once again, means everything that is metal and runs software. This means not just the cloud, but also the embedded devices that you're running, the MCU, the MPUs you're using on the field, the sensors, everything that is, let's say, physical or virtualized in if we're talking about the cloud, but even at the edge. Nowadays, we also have the grace of having virtualized infrastructure. Definitely not the topic of today's webinar. But anyways, infrastructure is really something where you start off, and when you make sure that you have the requirements you need for building your next product. And again, not the topic of today, but here we should definitely talk about and spare a lot of time by, let's say, that choosing the right infrastructure today, if we're talking about a data intensive product, is indeed key to a success, because balancing the load between the cloud and the edge is one of the hot topics. And when it comes to, let's say, building a weekend project or building a small project, it doesn't really matter. But when you scale up and when your costs scale up, it's becoming quite substantial in terms of determining whether you'll be successful or not. So infrastructure, I think it's anything but out of fashion, and it's something that has to be taken care of thoroughly before you get started. Then again, frameworks and platforms. And more than the IoT frameworks and platforms, you need to take into account everything else that stands either at the bottom or on top of it. Because the hot thing, of course, is making sure that you have a data integration layer that makes sense. This is really about making sure, once again, as I said from the start, that IoT becomes an actual data source that's feeding the company data integration layer, because out of there, you can generate both the insights you need within the company or the product or the project you're following, but also the right outtakes and insights that you need to deliver to your users, because ultimately, of course, you can leverage field data, but it is very likely that to deliver the product you're dreaming of, you need to integrate those data with something else. And I just put a bunch of the most popular tools that are usually deployed in the context of an organization, but even in the context of an open source project or something that we want to build amongst friends and see how it goes. So ultimately, choosing the right frameworks and platforms becomes instrumental, because the third stage is the development and integration. And this is really developer land. So where do you source developers? You source developers either within your own company or within your own group of friends, depending on what you're building. And this is what I would call the internal R&D. So your company, your organization, your team is in the business of developing software. As such, you are your own users in terms of the platforms and the frameworks you choose. But the market, of course, is giving you a lot of options when it comes to sourcing external manpower. And most of all, some of these people, some of these companies are already specialized and are already educated on the frameworks and platforms you chose. That's why it's a value chain, because ultimately the level of integration amongst the actors that you choose for your project will determine inevitably the speed by which you can deliver. Of course, if you build your knowledge from scratch, it's always a challenge, and that's where education comes out of. And when you talk about how this works within a company that is approaching new frameworks, new platforms, and new technology challenges, you either can train your workforce, or you can either choose a partner that is already skilled and trained in the technology you want to adopt. And usually, this is the faster and safest choice all around. So what do we do at SecOmind to make this transition meaningful and most of all fit into this scenario? Our product is named Clia, and Clia is really a platform that is trying to answer most of the questions and most of the requirements that I have outlined across this presentation. It is born out of the experience that we've had as developers in not only solving technology challenges, but also having to solve product challenges when it came to how do I build my own IoT product, my own smart device, or my own anything else. And we kind of find ourselves in the position in which we believe that right now, what developers, what product makers need is really something that can check all the marks across everything that I've mentioned over this webinar and deliver something that can make a stand when it comes to giving you the right tools, keeping you in control, and most of all, giving you enough speed to get there, but also, last but not least, be a part of a wider ecosystem you will have to build to make your product successful. As such, Clia is open source, and we release all of its components and all of its middleware stack as open source software on GitHub. You will be able to find links and the documentation in the collaterals of this presentation, but you can also reach out to me or to our team, because we are always on GitHub and we are happy to interact and discuss, especially if you have any ideas for new features or anything else. And most of all, it is meant for developers, but for developers who don't really want to reinvent the entire wheel. We give you all the tools and everything that we believe it's needed, but we, again, enhance our product on a daily basis, and we are happy to add more features to make sure that you can exchange and create your own data models in the lowest possible code way that can all then be, let's say, shared with the rest of your software ecosystem. Clia is really a platform that is focused more on data than it is on devices, albeit it provides the kind of device management features you would expect. But compared to other products in the market, it really doesn't provide data on top of device management, quite the other way around. Not only from a technology standpoint, because our data management layer, our device management layer is built on top of our data management layer, but also from a philosophy standpoint, because device management is optional, which means that you can also use Clia as a pure data platform for building your own data models and building your kind of algorithms or anything else on top, or your own data integration part that stands beyond the IoT communication. And of course, it is cloud agnostic and hardware agnostic in its entirety, which means that you can run Clia everywhere. We have a lot of SDKs for documentation, very simple installation and integration processes, and you can also build your own. So depending on the degree of integration that you want to have, you're always welcome to pick up your IDE and build your own connector or your own component to integrate with your favorite hardware or CPU. We usually just require SSL to be available, and this basically sets the stage for everything else. So it's pretty simple to do, and it's very likely that your favorite language and your favorite CPU or MCU is already covered by our own SDKs. Ideally, the reason why we believe that Clia makes a lot of sense is definitely that in this kind of scenario, we want to make sure that, let's say, our developers will find a friendly ecosystem in which they can really make sure that IoT plays well with the rest of the things out there. And most of all, to make it so we also have a bunch of software houses and companies who are already certified to work on our platform. And we have a growing ecosystem and community of developers that are already skilled on our APIs and our concepts within the platform. And it doesn't really want to force you into building something that has a specific shape or a specific something. We want to give you the tools and to make sure that you have the right tools to create. So we don't really believe in giving you a silo or something ready to go, which might tickle your satisfaction in the first 10 minutes, but will be a big letdown when you start running this in production and when you start being serious about what you want to build. We want to give you something that is easy enough across all the steps of your product management cycle, and most of all, that is always there to help you and to take away technology challenges from you rather than posing you new ones because you need the tools to adapt to your direction. We try and strive our best to be friendly towards developers, not really the other way around. And to do so, we also understand that most likely you already have another IoT framework or other things you are migrating out of, or you want to integrate because maybe you have the kind of infrastructure that wants to rely on more than a platform. CLIA provides you with a set of existing tools and pipelines to ensure that you can integrate with existing IoT platforms. And there's a bunch of migration scenarios that we can support by minimizing downtime and also making sure that you will not get disrupted in the process of migrating or adding another piece to your puzzle. So ultimately, we really are trying to build up a product that is very much oriented to developers, to those companies who want to differentiate their product and want to build something by, let's say, differentiating themselves, but without compromising on the speed and ease of use. So once again, we like to call it a Swiss Army knife if you're building your next digital product or smart product the way you want to call it. And that is definitely most of what I have today. I will be happy to take any questions. And then Max, this is back to you.
Well, thank you so much, Dario. That was very interesting. You struck a lot of chords with me. I'm a hardware designer by trade. And you know, when you started off by saying that the way hardware designers go about things, we don't redesign a CPU. we buy a CPU off the shelf, and we don't redesign USB. We use a USB device, and then we put the value added in there. And so that made a lot of sense to me, to be honest. And I also thought it was interesting when you said that this is not putting data on top of device management. This is putting device management on top of data management. It's data that's the key. Yeah. So
Absolutely.
Yeah, I was very interested. We have got we've got a load of questions in here. What's the main challenge currently faced by OEMs when it comes to dealing with the complexity of their product ecosystem?
Well, I will dare say that it's really the pace at which technology and demands evolve. And once again, if we accept the fact that users and customers are asking for more and more connected and smarter products in a way, this also means that keeping up with the customer's demand is becoming very challenging. And now most of the OEMs are really transitioning from maybe decades of inheritance of specific technology and domain expertise to something that now requires deeper technical knowledge of some areas that are completely new for them. I will say that the main challenge is really keeping up. And this is once again a great argument towards the fact that choosing the right infrastructure, making the right choices when designing products and infrastructures within the company is critical, because the right or wrong choice is really a make or break when it comes to production and maintenance. And definitely the challenge is the one I mentioned, but say that at the bottom of the iceberg is really, can I put together the right infrastructure? Will this infrastructure be long-lived enough to sustain my growth and my change needs? This is really what companies are struggling with.
Mm-hmm. Yeah, and also you were talking about using the middleware and frameworks, and I think a lot of people are, well, almost everyone's familiar with the concept of a hardware abstraction layer. How? But more recently, I'm seeing a lot of software abstraction layers as well. I guess you call those SALs to complement HALs. But again, the idea is to raise the abstraction so that you can change things underneath.
Yeah. Well, we've seen the rise of API gateways, for example, and there is definitely a very similar concept to the one of hardware abstraction layers. It doesn't really change much, to be fairly honest. It's always about putting a very thin API gateway that can then interact with the right frameworks downstairs. I think that this is really the inevitable consequence of adopting fragmented technology, which is inevitable at any stage, anywhere. There have been very successful products over the last 5 years that have been doing API gateway the right way. But also, I think that another thing I want to mention is that the cloud infrastructure itself has become virtually abstracted. And the most adamant examples will be Kubernetes and serverless. Serverless in particular is really decoupling in its entirety the kind of hardware in which your workloads run on. So it's the highest level of abstraction, if not possible, the highest we see today. So the concept of abstracting always goes hand in hand with making sure that you are not strictly and tightly dependent on a framework, whether it's software, hardware, or something else. So I will dare to say that once again, you correctly put when I finish my presentation, the hardware world is not as much different from the software world in a lot of principles, concepts, and philosophies. And eventually, what happened in hardware will happen in software. It may be with a different dialect, but we are seeing a very similar pace in direction in which the technology is evolving.
Yeah. Okay, how does the integration of intelligence and connectivity into pre-existing and also new machinery impact the OEM's daily technology ecosystem management? And also the follow-on, yeah. And just to add a little bit of cream to the cake, how has the data acquisition process usually been performed?
That's another webinar,
Wow.
but so trying to summarize. Let's. I will give you a bit of my experience because I don't think there's a one-size-fits-all approach here, right? So ideally, the different companies, different products take different approaches. Some are born connected first. Most cases I see are usually connected later, again, because of maybe a very big and relevant inheritance back in the days. I believe that usually companies start retrofitting their devices once they grasp the opportunity of having their devices connected. So retrofitting is anything but a non-cumbersome process because, of course, you need to deal with a huge fleet of existing devices. Some of them might have been forgotten. Some of them you may not even have the knowledge on how they work because these things really happen. I mean, if a product is like 15 years old, you maybe all the people that worked on it have left. You have no documentation whatsoever. So these used to happen.
The old definition of an embedded system was one that you didn't even know was there until it stopped working.
I will definitely take that, and I will spare myself and yourself from giving you examples, but I've seen this happen quite a number of times. So yeah, the challenge is huge, and ultimately it goes hand in hand with productivity. With opportunity. Sorry. So ultimately, what we try to do is this. Once again, if you put the focus back on data, it becomes slightly simpler, because usually, at least in most cases, newer machines are just a superset of the data that the old machines used to manage. So once you can model your data effectively, and that's the concept also we start with our product. So you start not by defining your hardware, but defining the data your hardware can handle. And if you do that, it is much simpler once again to abstract, because our layer of abstraction really is data, because ultimately there's no escape. If you need to retrofit 7 different kind of machines that have 7 different protocol buses and 7 different ways of interacting, you would have no escape whatsoever. You need a layer of abstraction. To us, the layer of abstraction is always data. So, and we usually place the bet that a 20-year-old machine will not be producing as much data as a newer machine, but ultimately it's the same machine. If you buy a car, it still has 4 wheels, right? Unless it's a motorcycle. So we try to put our abstraction layer at the data layer, and this has been proven quite successful. So ultimately, the way you ingest, then it's decoupled. And there is really no answer, because I've seen countless times people trying to build a one-size-fits-all approach to collecting data from the field, and none of them succeeded because there is no way by which the fragmentation at the field level can be somehow solved. And that's you need to deal with that. So ultimately, our bet is we don't abstract at that level. We abstract one level above. And the data ingestion, really, I've seen everything. So the answer to that question is it really depends.
I think the one size fits all is very important, or the fact that there is no one size fits all. And when people say no code, alarm bells start ringing in my head, because that says there's no way to do the fine tuning. And so it's when you were talking and you said low code, that makes me a lot happier. That I have the
But that's just because
ability.
me and you are programmers.
Well, it's also this is where you do the value add. You know, with your knowledge and experience, this is where you can
Absolutely.
take what's there and you can add the magic, the secret sauce that makes
Absolutely.
it, that makes it different.
Absolutely, and I believe that really you hit it on the nail because no-code frameworks used to be all the rage a couple of years ago, and everybody was talking no-code. Now, low-code is a little bit back on track because, the delusion of realizing that no-code implies a lot of limitations has hit a lot of people who thought that
Right.
this was basically the case. But we all know it's not like that. So
Well,
I
it
think that
sounds
really.
good when you say it quickly.
Well, quicker than I thought. Let's say that quicker than I thought. But I've seen other trends fade off in a much longer time frame than the no-code trend has faded out. Even though we still have, there's still a lot of areas in which no-code makes a lot of sense. Don't get me wrong. But definitely, when we're talking about building a product, building a value add on top of it, you have to code because ultimately, if that was not the case, everybody could build your own value add. So something is off. Or the value add you have is not lying in software, which might as well be. But this is again part of the decision-making process of those who build the product. Ultimately, I believe that still there's a lot of ways to reduce the code you write and to do it in a smart way because a lot of programmers, a lot of developers have seen it happen countless times. We have jokes around it. Everybody has in the developer community that people really keep reinventing the wheel. And there is a really, I think that the most successful projects start with the correct understanding of what's to be owned and what's to be sourced. And that is really the deal breaker or deal setter.
Yeah, you focus on where you can add a difference.
Yep.
Yeah. How can OEMs facilitate the development of applications by the system integrators?
Well, it's it's a more of a chicken egg question, right? Is it more like you need system integrators to adapt, or you need OEMs to go the way the system integrators want? Ultimately, I think that OEMs can really help themselves, first of all, in making sure that they make sound choices when it comes to something that can be integrated. And usually this really comes down to the right architecture design. Because system integrators, software houses in general, will like to work not just on something that they know, but on something that makes sense to them. And depending on the OEM heritage, the OEM might be more or less focused on the software bit. If they are less focused on the software bit, there is a very high chance that they will get the architecture wrong on the first round, no matter how skilled is the team. But if it's your first time doing this, you will eventually fail. So I think that the way that by which OEM can do this job in a better way is involve them earlier in the process. Because if you can get your system integrator to act as a consultant for you, you might at least be spared from some wrong choices, or you might as well confront yourself with different ideas, and then maybe you're right and they are wrong, by the way. But having some kind of measure by which you can determine whether you are steering off a reasonable path or not is always something very good, and then it really helps the whole value chain. But ultimately, OEMs system integrators can also help OEMs doing the right decisions by not being greedy and ensuring that they don't reinvent the wheel themselves, which is something that has happened quite a few times, of course. So I think that if the value chain and the ecosystem plays correctly, software houses, system integrators can bring their own experience in building architectures and executing them, of course, whereas OEMs can measure the efficiency of the architecture that's being built based on the understanding of what has to be owned and what has to be sourced. That is definitely probably not the magic formula, but at least it's going to help.
Yeah. This is sort of related. So how can the approach to an internal data and services management be changed for the OEMs in order to create new business models that bring together hardware and software expertise?
Well, that is a very thorough question, to be fairly honest, and it is definitely not the first time I get asked this question, not in the context of a webinar, but a lot of customers maybe come to me and ask me something like, "Hey, what can we? It's all fun and games, but we need to make money out of this service. What do we do, right?" And most of all, sometimes they have the right ideas, but they lack the execution layer. So they lack the people, they lack the infrastructure. Once again, I think it's really a matter of balancing out your core business from what you need to source. Just as in probably you mentioned before, you don't build your own CPUs, and no hardware companies will ever think about bringing in a CPU expert within their realm unless they're building CPUs. Companies who want to make a switch to software should source the skills on the software market that matter to them. And usually those skills are in management, because you need to, most of the times, to manage different providers, talk with the system integrators, apply measures of control to the deliveries. I've seen a lot of people falling out of bounds because they were not capable of measuring the quality of the deliveries they got in the right way, which is anything but trivial. So
Yes.
ultimately, you really need to build the infrastructure for control first. And then you need to evaluate in a very peculiar way, what is the kind of execution team you need to have on board. So it is a difficult and thorough process that takes years in the case of bigger organizations. And I think it has to be done step by step by privileging control before anything else, and then moving up to execution once you understand what you really want to insource and what you want to source outside.
Okay. Everything you say is setting new ideas running around in my head. Okay, another question. What role do IoT technologies play? I'm not quite well, there's no definition of what's an IoT technology, but what role do IoT technologies play in the creation of a technology infrastructure that allows data ingestion to be managed simply and immediately for OEMs?
Well, it's a broad question. I will be biased if I will say that ours is definitely one of the kind of technologies we OEMs need to adopt, but I will be biased and I will say that because I still think it's quite a foundational component. So you definitely need a platform that is a data platform designed and let's say built for IoT and built for integration on upper and lower layers. It's definitely, I will say that nowadays it is super important to have a grasp. I will not say the obvious things about gateways, hardware, devices, NPU, MCUs. It's something very consolidated. Not the best person to talk about this. I will definitely say that right now, looking at new technologies in the cloud space, so especially all of the ML engines that are being born out of the competition between the cloud giants, and everything that is coming out of the, let's say, artificial intelligence second wave that we are about to witness, are some tools that the companies need to make themselves familiar with. Because of course, the next challenge that follows the collection of data is the processing of data. And ultimately, these tools are very new. These tools are not mature yet, as in not consolidated. I will use the right word because some of them are really mature, but not consolidated just yet. And being confident with what at least these things do is really instrumental for building new products in the future. And if you ask me, are these IoT tools? I will say incidentally, yes, you cannot put them out of the picture if you're building an IoT project in 23.
Okay. We've got a ton of questions here, but they're all over the place, and you will answer them, as you said, later on, any that we don't get to. So I'm going to, I've got two myself, okay? And they sort of gather together a lot of things for people. So as you've already explained, Clear is a software suite that provides OEMs with all the starting tools to optimize the product's ecosystem and rapidly develop value-added solutions. So just for the people who came in a bit late, what's the main platform functionalities of Clear and its business model?
So the main functionality is really about being capable of defining the data models that will be exchanged between the field and the cloud. So this is really the foundational feature out of which everything else then sparks. So this really allows you to define a device not about what it is, but about what it can do. And of course, this, as I mentioned before, also serves as an abstraction layer to, let's say, deploy CLIA across all of your fleet. So the ambition that the product has and the main feature, I think the killer feature, is what really stands at the foundation of it. So being capable of representing the most diverse fleet in a simple way, and most of all, delivering abstraction by default. So making sure that you can integrate existing devices in the fastest and quickest possible way. Then I think that the second killer feature is providing commoditized feature on top. So by the means by which the platform is built, we have a full device management suite, which is built on top of the main data management and data exchange layer. This is pretty unique per se. And of course, this really gives you the flexibility of adding this component if you need it to be around, or not adding it if you don't need it to be around. But most of all, and this will be the third killer feature, it really enables you to build your own components that act as an extension of the platform and can then interact with the rest of the appendixes that you put around the platform, whether it's your front end, it's your back end, it's your data pipeline that goes to your CRM or something else. But ultimately, as I always try to pitch it, it is your central hub out of which all of your field data is managed, and it's then, let's say, shared with the outer and the inner world that you have. And our business model is pretty simple. First of all, the platform is completely open source. So the business model for free is that you go on GitHub, you download everything, you read the documentation, you install it yourself. If you want our help in running it, or if you want to source the platform as a service, we do both. In that case, we always charge a monthly subscription in the most SaaS or PaaS friendly way that you guys are surely familiar with. And in that case, this subscription is always metered on volume, so depending on the kind of support you require and the amount of data and devices you exchange.
I just love the fact it's open source, because as a user, that always gives me a great feeling of confidence. Okay, Dario, I think we've got time for just one more question. And as I said before, I think I'll keep this question for me. While I ask this question, Dario has told me that you can feel free to contact him directly using the contact details that's shown on your screen right now. So just to summarize everything we've discussed today, what do you see as the outlook for the future of OEM's data management and related new business opportunities?
Well, I mean, it's looking into the future is always a challenge, right? And I have no crystal ball equipped, but if you ask me for my personal thoughts on where I see the market going, I believe that OEMs will have to answer to the main challenge of evolving what they do in terms of stop selling their products and start getting their customers to subscribe to their products. I mean, if you look at the automotive market, which I believe is always the reference when looking ahead in the industrial market, car companies are no longer very keen on selling you cars. They are keen on you subscribing to their cars or subscribing to the services you have within the cars. And once again, this is nothing short of what has happened in the mobile market, which we all know is quite a few years ahead of both when it comes to innovation, in which telecommunication companies wanted you to pay monthly for your phone without selling it the phone. And then we had the apps, then we had the microtransactions and everything else. Of course, it is impossible that all of this will come to the industrial market. But if we know that history usually repeats itself, it is very likely that OEMs, and some of them, which are amongst our customers, are already thinking slash doing this, are going to provide products no longer as a wholesale, but as a subscription. And maybe in 5 years from now, it will be very likely that we will see industrial machinery, a lot of different equipments, no longer just leased, but subscribed to, in which you will just no longer have an insurance selling you the product and having you a lease that is lasting for 36 months, but an actual subscription, and something that really resembles what's happening in other environments. And of course, this is pretty obvious because, as I mentioned in the beginning, all of this really boils down to the fact that OEMs really have the problem of keeping their customers close. So this really helps on a full scale of different things. And ultimately, I think that if the destiny is to keep your customers closer, it means giving them better services, giving them more data, and giving them their products they used to use and they maybe love, hopefully, in a completely different fashion.
I agree. Funnily enough, I've been talking to some automotive manufacturers recently, and they're talking about a future where they may add extra hardware into a car that they don't charge you for when they sell you the car. But then a year or two down the road, they have an additional revenue stream because they can turn that hardware on. You know, additional
Yep,
sensors, new capabilities.
absolutely.
Very interesting. Well, thanks, Dario. So this brings today's webinar to a close. Thank you so much for viewing, and I'd like to give a special thanks once again to Seco for their sponsorship, especially to Dario, of course, for his insightful presentation. Once again, this is Clive Maxfield, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And until then, from all of us here at IoT Central, we hope you have a wonderful rest of your day.